Okay, guys, last thing we want to do, we did adding, we did subtracting, we did multiplying, so we want to do dividing. Find each quotient, write your answer in form a plus bi, that's standard form for a complex number. Now, when you do, I guess it will say division, in this case, you're sort of doing it, but you're thinking more about getting it into this form, okay? So how do we do that? Well, we're going to use complex conjugates because remember in the last video, we talked about how we don't want any imaginary numbers on the bottom because that kind of ruins everything here, okay? So what we're going to do is we're going to get the imaginary unit out of the denominator. The way we're going to do that is we're going to use the complex conjugate of the denominator. So if I look at this denominator, the complex conjugate is the same thing, just using a minus in between. And so I can write something like this, 3 minus 2i over 3 minus 2i. I'm going to multiply this whole fraction by 3 minus 2i over 3 minus 2i. So maybe you're saying, hey, what do you mean? How can you just multiply it by that? Well, be careful here. What is this equal to? What is anything divided by itself? It's equal to 1. Can I multiply something by 1 without changing it? Of course I can. I'm just being a little tricky here so I can get rid of the i's on the bottom. That's why I'm using always the complex conjugate of the bottom. Now I have a binomial times a binomial and a binomial times a binomial, so I got some foiling to do. So first things first, 14 times 3 is 42. Then I'm going here, this is my outer. 14 times negative 2i minus 28i. 5i times 3 plus 15i. And finally, 5i times negative 2i is negative 10i squared. Down low, you can probably guess already there aren't going to be any imaginary parts. Let's make sure. 3 times 3 is 9. 3 times negative 2i is negative 6i. 3 times positive 2i is 6i. When you add those will cancel just like we want. And finally, 2i times negative 2i is negative 4i squared. Okay, so let's continue from here. And remember, our I squared is equal to negative 1. So from here, let's see, I got a 42 minus a 13i minus a 10 times negative 1, which is really a plus 10. Down low, I got a 9 minus 4 times negative 1. So that's really like adding 4. So you might be able to see where I'm going with this. Okay. So I got 42 plus 10 up top. That's going to be 52. And I'm left with a minus 13i. And down low, I got 9 plus 4 is 13. I think I'm getting closer to here. In fact, this looks like one of the problems we sort of looked at. And from here, I know that I can say, okay, well, this is 52 over 13. I'm splitting the numerator like before, minus 13i over 13. Well, 52 over 13 is 4, and 13 over 13, well, that's just 1, so that's just minus I. There we go. That's the answer to the division problem. That's the quotient. Okay. If we look at negative 6 over I wanted to show you that one because it could be a little tricky, but the important thing is to realize that I is equal to 0 plus I. Knowing that, it's easy to see that the conjugate is negative I, the complex conjugate to be exact. Let's see what we get. Negative 6 times negative I, well, that's positive 6i. Down low, I times negative I is negative I squared. Well, that's 6i over negative 1. So that's just going to be 6i over 1 or 6i. And there's your division. So remember, when you're finding quotients, when you're dividing these complex numbers, always look to the bottom, multiply by complex conjugate over itself. Simplify, remember that I squared is equal to negative 1. All right, so that does it for 1.3, guys.